Secretary TRAI to kindly begin the session with his opening remarks and to carry forward the proceedings of the session. Over to you, sir.
So wherever you are comfortable.
Good morning, my esteemed fellow panelists and industry members and various other stakeholders. Very good morning to all of you, and let me thank ITU-APT Foundation of India for having invited me to be there with you on this session. I will not be speaking anyway something new to about the captive networks. Whatever we have to speak, and whatever we have to do is through the recommendations. That is one of the key virtues of TRAI, that we will not speak and give individual opinions and then opinion of TRAI. So we will speak, whatever we speak is through the consultation process and then also through the recommendations. So coming back to the today's topic on CNPN, as you all know that India is actually moving towards becoming a global hub for the manufacturing industry. And also there are several innovations which we have seen that India has potential of the innovations coming up. And also the various kinds of captive networks emerging, especially for the ports. Airport, you take airport or the ports or the mines or even the institutions, etc. So these are all the things where there is a huge requirement of private networks being established for their own efficiency improvement and then their own productivity improvement and then their economic development, and which in turn captures the whole economic development of the country. So this keeping in mind, this is the emerging requirement. So and also there are around, if you see that 70 million MSMEs are there in India. So these MSMEs also required to be upgraded to the new 5G and emerging technologies. That is very key important. So TRAI has kept at the back of mind that one of the key things is the MSMEs to be also upgraded to have a 5G networks and then captive networks if they have to improve their own efficiencies and being the total part of the economic development. That was one of the key parts. So keeping all these things in the back of the mind. And also we have as TRAI's mandate is that to keep in mind the service provider's interest as well as the consumer's interest and the overall economic development. So we have to balance between the service providers as well as the consumers. So this role is very, very critical in this whole process. So we have kept in mind about the balancing the service provider's requirement and the end user's requirement. So with this actually we have given our recommendations. If you recall, it is around, today again I have taken the printout and kept with me. It is around 13 pages exclusively on CNPN, and around the discussion part of the CNPN is around more than 100 pages, chapter on that. So we have dealt extensively on the CNPN networks, and we have given the choices of recommendations. That one of the three things which I highlight before moving on to back to my place, that is, we have given the choice to the service provider to provide it through network slicing and also to establish an independent network of the in a enterprise, and also to lease out the spectrum to the enterprise. There are three major options which we have given to the service provider, and in addition to that, one option also we have given to the enterprise. If he wants to own the spectrum, if enterprise wants to own the spectrum, they can own the spectrum. But we have also specified that there should be 100 crores networks should be there for that. So that means there is a major, which I have stressed that at the back of the mind was MSMEs. The MSMEs and all will not have a 100 crore network. So there is a major market for the service providers, and also there are certain things, options given for the manufacturing enterprises to become a global hub for them to use this if they want captive purpose and then develop. So we have tried to address actually the balanced part of in the sense to give the options to the service providers as well as to the enterprises, to give a scope for the expansion for the MSMEs to keep in the back of the mind. So this is very, very holistic. And also spectrum part which we have mentioned is that there are we have not actually recommended anything which is part and parcel of the IMT. IMT, they can always use, service providers can always use the IMT for the captive network. But at the same time, we have suggested a very isolated, which is not used spectrum like 4800 to 4900, suggestive part of it. So we have kept in mind the spectrum, the MSMEs, the service providers, the end users, and if you see that, the very holistic and broad, extensive recommendations we have given. So I look forward to for any further discussions and then questions, and then if maybe questions are to be answered. And also, I would like to keenly listen to my fellow esteemed panelists for this. With this, again, I thank you all for inviting me. Thank you.
Thanks IFI for inviting me to deliver this keynote. It's indeed an honor to speak about captive networks in front of such an august audience. So, we have heard through the last 2 days quite a bit about the need for spectrum in various segments of the industry. We heard from defense, somebody asked about agriculture, there were some speak about other types of industries, manufacturing and so on and so forth. So there is a large amount of awareness that has already been generated thanks to all the actions taken by the government, that there is a need for some solution for enterprises and industries to have a network of their own, to run their mission critical operations using a network that can be future-proof for them. So I'm going to give you a glimpse about what are the options that industries have, and what are the ways that they can set up a network with. Right? I'm not going to give any information about any controversial subject like which spectrum to use or what to use and things like that. I'll try and limit myself with the technology part of it. I will let Mr. Raghunandan and others speak about which spectrum and how to deliver and things like that. So what I'll speak about is a little bit about, what are the requirements if enterprises, why are they asking for such a, private network or a captive network. I'll then talk a little bit about if you need to have a dedicated network for an enterprise, what are the needs, what all should it satisfy for it to be, any technology for it to be ready for a dedicated network, and then what are the options available, and then a little bit about how to implement this private network or a captive network. If you look at some of the key asks of digital transformation, or any transformation for that matter in an enterprise or an industry, there are 4 key areas where they need to focus on. And this is all economics and business, and nothing much about technology. They need to worry about using their assets, sweat their assets. The assets could be machines, material, or any of those. How do you take out a lot of data and then automate as much as you can using the data that is there? How do you use AI, ML for doing your automation? How do you improve the operational visibility of the network itself? And how do you create a safe working environment for the people who are working there? At the same time, there is a pressure of multiple technologies that are being played in front of them, like in IoT, digital twin, cloud, edge computing, AI, ML, AR, VR, cyber security. There are quite a plethora of technologies that are being played in front of these people. If you look at these enterprises and industries, they have a specific mission based on their own respective industry. If I am a car manufacturer, my focus is towards manufacturing car. I focus towards how do I design newer and newer car, how do I remain competitive, how do I ensure that my manufacturing setup runs efficiently and things. The focus is towards their core competency, right? But then at the same time, they have to, sort of adapt to quite a lot of new technologies that get played in front of them. So if I have to set up a network that satisfies all of these requirements, then I require a few things. I require good bandwidth, with using which I can connect multiple applications within the campus. I require, high density of devices. I shouldn't be constrained by how many devices I can connect. I should be in a position to add a device, remove a device, shift a device as much as I could. I require good amount of security. The latency should be low. There has to be a reliability of the network itself, right? And then the technology that I'm using should not limit in any way the mobility of my equipment or devices. I should be able to rearrange. I should be able to move the devices here and there. I should be in a position to have that device fitted into a machine or a vehicle that is moving inside the campus and so on, right? So the technology that I'm adapting should not limit me from achieving any of these things, right? So that based on that is what we can recommend to the enterprise, to the industry, which technology that they can use for achieving this. So the challenges are primarily collecting a lot of data and analyzing them, having secure data, and finally mobility, right? So these are some of the critical challenges. If I construct a dedicated network, that means I am able to connect all the devices or all the machinery within the campus to a network that is secure, that is inside my campus. I have the full control about it, and I am also using based on a technology that provides me all the flexibilities that I spoke about in the earlier slide, right? So I set up a network which is able to satisfy all of the conditions that we said in the earlier slide, and hence I get a reliable network. I get full control of my network. I don't have to depend on a third party. A third party could be a service provider, maybe the third party could be anybody else. So I don't have to let the control be on a third party's hand. I would do it on my own wish, based on the business needs that I have for my enterprise, my organization. And I should be able to protect my network from external threats. So the moment I start connecting millions and millions of devices to the network, that means I am getting connected to an possibility of an external threat that comes from the external world, either through the connectivity or even through the radio interface that they have, right? So there could be a potential threat that could happen, and I should have all the controls that I can put together for managing this threat. And finally, I should have a flexible operations, right? With all that, I can either have a captive network or a non-captive network, as the title suggests. So what are the options that are there, right? So far, people have been connecting these devices probably using a wired network. The wired network could be a Ethernet, could be all other industrial interfaces, but that comes along with that is an inflexibility. That means I will not be able to move around the connection as I wish. If I have to add another connection in a running factory, we need to realize if it's a factory, then we need to probably even sometimes halt the process for you to add another device or to do another wiring to connect a device. So what happens is that any wired network sort of poses a lot of challenges. The other option is to use other Wi-Fi technologies like Wi-Fi, LoRa, Bluetooth, low energy, etc. But each of them provide certain connectivity for an area, but when it comes to covering all sorts of applications across the entire campus, probably that particular technology is not going to be suitable for delivering that. And hence, cellular data is the one which is turning out to be probably the best alternative. Provides you good data bandwidth, gives you low latency, can cover almost all the use cases that are being played, starting from very low bandwidth, high reliable use case like connecting to a machine, all the way to a video analytics or a computer vision type of high bandwidth application. A cellular network can sort of cover all of this, the entire plethora of applications that are possible. The one problem that comes with this is the device ecosystem is not as mature as what happens in Wi-Fi or a Ethernet network or industrial connectivity. So there is still issues with respect to the device ecosystem. Barring that, you could potentially connect all of the devices and run your entire operations within the campus, irrespective of which industry it is. You will be able to run all of that using a dedicated captive network. So one may argue that why can't I do this with a non-captive network? There are a few issues that we have to keep in mind. Number one, the priority that would be for the person who is providing the non-captive network. So the prioritization of enterprise versus consumer. So do I put a network that covers millions of consumers who get connected, or do I focus those 1,000 devices inside this, say, 10 square kilometer area? So which is the priority that I have? Given the spectrum that I have, given the type of devices that I have, where do I prioritize? So second is, assuming that you somehow manage the first point, how do you provide an uncontended spectrum? Because we just spoke that it is a mission critical operation that the enterprise is doing. Let's say they are manufacturing, say, steel. So when they are manufacturing steel, the blast furnace has got thousands of sensors. And now if there is a problem in this network, or if there is a contention in the network that happens, for example, in a signal when you go and stand, there are hundreds of vehicles around you and the performance drops down on a public network. The same way, if there is a contention, how does this blast furnace work? Could there be a hazard, health hazard or a safety hazard that can happen because the parameters of the blast furnace are not controlled by the PLC or the SCADA system that is connected to it? So can there be an uncontended spectrum or bandwidth that can be provided to the enterprise, sliced out of whatever is the spectrum that the operators have? What about the uplink and downlink profile? Suppose I am doing a computer vision. Let us go to the same steel plant, and if I am using computer vision to do the quality assurance of the steel that's coming out of the plant, right, using high density cameras and watching the surface of the steel and looking at if there are any aberrations on the surface of the steel, and I am using multiple high definition cameras to do this, right? That means my network has to become uplink intensive. Now typically a consumer based mobile network is a downlink intensive network, right? You are using it for watching videos, movies, various other things. So how about the downlink and uplink profile? And what about the security of the data that is being collected? Because it is a mission critical data that is being collected in the network by PLCs, by SCADA, by video cameras, by various other equipment that is inside the enterprise. And the security of the network itself, because you put maybe base stations inside the campus, and how do you secure those? How do you protect it from an external attack, right? These enterprise applications, many of them being very mission critical and latency sensitive, many times they run within the campus. If I'm running a PLC, programmable logic controller, to manage the blast furnace, in all probability my application sits inside the campus itself. It's not going to sit somewhere else. But then if I am going to use a non-captive network, the packet core or the function where the data comes out of the radio network and gets into an IP network is going to sit somewhere in the customer, in the operator's data center, somewhere in the world. We don't know. Whereas if it is a captive network, the application can reside right there within the enterprise campus because the function called UPF breakout or a CUPS architecture that 5G mobile network provides. And finally, how do we commit to latency and other QoS parameters? So these are the various challenges that can happen if you are trying to use a non-captive network to run a mission critical application, right? So then what is the solution? How do we go about? We implement let's say we have to implement a captive network. Now a dedicated network, the RANs are dedicated, the RAN is dedicated for the enterprise alone, and the SIMs that are provided along with that work only with that network. There is a local breakout for low latency where you can provide edge computing capability or connect to the applications that are controlling that particular enterprise's mission critical operations. You can restrict the access to that particular network using the SIM profile and the SIM identity. You can implement, manage and operate by the enterprise themselves, or probably with the help of a third party system integrator type of a company which helps them. And applications on the end devices are as per the enterprise requirements. The bigger problem here, which still remains unresolved, is how do you get a spectrum for that? There are multiple ways one can look at, like Raghunandanji mentioned. You can have probably a slice from the network of the operator, you can get spectrum from the operator. It is all feasible. Only thing which we need to make sure is the problems that I mentioned in the earlier slides, are we able to solve all of them? Various countries have taken multiple methods to this. They have dedicated a set of frequencies and said that this is meant for industrial use. Many countries have already taken that stance. There is a recommendation from TRAI as well to do such a thing in India, right? Some countries have gone ahead and said that you will use a shared spectrum, and there is some sort of a cognitive implementation which measures the strength of the network and says that within this campus, this spectrum is not being used, so that spectrum is used for radiating within that campus. The moment you step out of the campus, that the same spectrum may be used for public networks. So there are some such thing which has been implemented in some countries. UK, for example, has implemented a shared spectrum capability. CBRS in general in the US is implemented the same way. There is somebody called a SAS provider who just tells you whether you can radiate in this particular spot frequency inside your campus or you can't radiate. Okay, so there are, and if suppose none of these things work and you have to go to an operator to release a spectrum, it is important that the operator has got enough amount of spectrum so that they are able to cut off a piece of that spectrum and provide that for the enterprise, and that will not interfere, or external implementations of consumer mobility will not interfere with that implementation inside the enterprise. So on the spectrum, there are quite a few things that we need to do, and we have to enable this. Just to give you a view, there are lakhs and lakhs of large enterprise campuses in this country. Apart from that, like the speaker before we mentioned that there are multiple millions of small and medium enterprises. So if you have to enable all of them to implement all the digital transformation and make them be competitive in the external world, and they have to use technology to do this, then it is important that we help them in some form. If we simply say that you have a contented bandwidth or a consumer spectrum that has been allocated to an operator and let the operator help you, may or may not be the answer. There could be alternate ways. Both sides, probably from the operator side, they have to take certain steps. At the same time, probably from the government side, they have to take certain steps to ensure that this spectrum is made available to the enterprises. So, you set up a network like the RAN and the UPF, and there is a MEC inside the campus, and core can run within a central location somewhere, within the enterprise, or can be in a network which can be across enterprises. But what is important here is when you say you are setting up a captive network, till where do you want to draw the line? Is it only the RAN that you want to do it, or RAN and UPF and MEC, or RAN and UPF alone? MEC is provided by probably a cloud service provider, or the entire thing has to be done by the enterprise. So there are multiple places where you can draw the line to say that I am setting up a private network, as long as the conditions that I mentioned in the earlier slide, the QoS, uncontended bandwidth, security, data privacy, application on the edge, all of those points can be sorted out. You can use any method to set this private network up. The key problem still remains is the device ecosystem. Probably today you have devices which can talk the industrial interfaces. They don't have the ability to talk IP, or they don't have the ability to have a native 5G or a 4G radio inbuilt. So you may have to use certain CPEs to convert probably what is 5G or 4G into an Ethernet or a Wi-Fi or one of those broadly available protocols to connect the devices. So that will be the only one issue that will still remain for us to solve, and probably it will take a couple of years more before the device ecosystem also warms up to the private network. I'll just give you one example where there are such things that can happen inside a manufacturing setup, and this is my last slide. So there could be multiple use cases, and if you look at some of the use cases that I have mentioned here, each one of them will require a different characteristic. So if I am going to use a video analysis or a computer vision, either for surveillance or for quality assurance, I require high bandwidth, I require uplink intensity, right? And latency is okay, there's not much of an issue there. Whereas if I go and use this for, say for example, yard management, where I am automating a set of cranes, right? I will still go to the same steel industry, and then look at if I have to automate the cranes that are used to lift the steel rods and then ship them into the train, right? Now I have to automate this entire process. If you observe, if you have ever visited a steel industry and if you observe the yard, they are pretty huge, very hot environment, and it is not easy for a human to work out there. Similarly, there are lots of possibilities of error for a human, right, who is operating the crane. So now many places people are trying to replace that with the automated cranes, and that requires a connectivity. Wi-Fi cannot work there because it's completely steel. You can imagine that. We have done some trials and we found out probably a cellular network will be able to solve that problem. That particular application will require a very low latency, small amount of data being transferred once in a while, maybe a couple of Mbps, but then the latency requirement is extremely critical because you are lifting heavy steel and moving that from the yard to the rail, right? So those type of applications will require low latency, maybe lower amount of bandwidth, but very high reliability. The network cannot go unfunctional, non-functional at all. There cannot be a downtime, right? So that's a critical stuff. So if you, and for example, if you go to condition-based monitoring of the machinery, right, which provides preventive or proactive solution for any downtime of the machinery, there you will require again equivalent amount of latency, lower latency and higher bandwidth. So each of these applications that I have mentioned in this slide will have different types of network profiles that you need to configure. If I'm going to use a public network or a public network slice, I won't be able to configure different network profiles within this, right? Hence, even whosoever provides the spectrum, whosoever implements and operates this network will have to be in a position to provide these different types of network profiles for this enterprise to run this network efficiently, right? So that's the ask from the enterprises. We have been talking from Tata Communications, we've been talking to hundreds of enterprises in India and abroad, and we sort of we have collated the nature of demand that comes from these enterprises. And this is, whatever I just now spoke, is a sort of a culmination of various conversations that I've had personally with multiple enterprises. Hopefully with this panel and this discussion today, there would be some fruitful outcomes that can come out for providing captive networks for enterprises. Thank you.
Before we have the panel discussion, we have one more keynote presentation for which I would like to invite Shri Sanjay Agarwal, DDG Disaster Management, DOT.
Good afternoon. Yesterday we were talking about that metaverse and AR and VR and other things are the buzzword for the industry. At the same time, the sustainable development goals and creating disaster risk resilience networks and creating early warning systems is another goal at the global level agreed by all the nations for public goods and for long-term development. And for that, the technology holds the key. So I'll cover about that public protection and disaster relief network. So there is a TRI recommendation to that, and then thereafter I'll talk about what are the existing network of public protection and disaster relief agencies. What is PPDR network and what are its features, what is global experience, and then building PPDR network in India. So TRI gave its recommendation for creating a pan-India integrated network for communication among public protection and disaster relief agencies on 4th June of 2018. And that I'll just share what are the public protection and disaster relief agencies. So when we talk about public protection agencies, these are police, fire and medical services. And when we talk about disaster relief agencies, so disaster management is a state subject, so SDRF and SDMAs are at the state level, then there is a agency called NDRF and then NDMA at national level, which supports the states for disaster management. And there are other agencies like paramilitary forces and of course the defense services. So what kind of communication they do have today, that for that short distance communication, they have got VHF and UHF or radio trunking services like P25 and Tetra. And for long distance from one district to other district, they use HF, VHF and Polnet. Polnet is a satellite based communication technology. And the last point which is mentioned in the slide is the mobile and the telephone. And this is the very unfortunate part, that they rely heavily on the commercial network which is not designed to cater their need. Similarly, when we come to disaster relief agencies which are NDRF and SDRF, so they have the radio portable equipment which they deploy when it is really required. Otherwise, for long distance, they have got the satellite phones and they have got VSAT terminals also with them at NDRF level. Again, they depend a lot on mobile and telephones. So at present, each category is, each agency is having its own analog or digital network which is working in silo. One agency cannot speak over the dedicated network of its to the other agency. And of course, the analog network are having security risk. And we had done a study about the different states like Gujarat, Rajasthan, Delhi and other states. Even for the movement of very, very senior dignitaries of government, including the top government leaders, they are using the analog network to talk about where the next movement of Prime Minister is going to be there. So that is a major security risk, and again they are using WhatsApp groups. So this is the current status. What is the limitation of the present day network? That is, it is inefficient use of spectrum. Of course, they are using frequencies in 400 megahertz band and then again 800 megahertz band. Congestion during emergency or disaster, the network may get congested. Then interoperability, as I said, that different agencies cannot speak to to each other. And even in the police network, they have got multiple systems installed for communication, P25 or maybe some analog also, and then some VHF based system also. So when there is a VIP security or some other thing, so the officers will have to carry different mobile handsets, different handsets with them. Security, of course, as we have talked about, that it is non-secure, and this technology is getting obsolete. And as we have seen that at various places, the OEM has declared that it is out of life equipment and there is no support. So they are taking support from local agencies, which is at a very high cost, and it requires upgradation. So when we come to PPDR network, it is PSLT based network. So the network is that the existing 4G network, or maybe it can be upgraded to 5G. So existing 4G commercial network is strengthened to meet the public safety requirements, and wherever there is a coverage gap, then additional coverage is provided by installing towers. And at the back end, there is a mission critical communication server which meets the requirement of the police or other disaster relief agencies for the PPDR purposes. This is how the system architecture is. This is 3GPP compliant, so it can seamlessly be upgraded to 5G, and which is already being in US. We'll discuss about that also. It is integrated across agencies, across cities and states. Video, photo and location can be shared in mission critical mode. Group calls are possible for even video, data and location sharing. I'll talk about the use cases of all of these. Then wearables, that body sensors on commandos going forward in any critical operation or disaster rescue. I'll talk about that in the use case of PPDR network. Then whatever is the present network, it can be seamlessly be integrated with that. The capacity is that it is designed to cater to the need of the extreme events, and the spare capacity is used for commercial purposes. Reliability is, of course, that at the back end we have all sort of connectivities depending on the requirement, OFC and then radio and the satellite. So these are the use cases. since this network is integrated, it can share video, data, location in mission critical mode. It can be upgraded to 5G, and it has been done in US. And dynamic grouping is also possible. So we take one case of terrorist attack. Let's say that there is some terrorist attack in Ghaziabad, and then the terrorist group is moving from Ghaziabad to Noida to Delhi to Gurgaon. Now what happens in the present day network, that Gurgaon police, Ghaziabad police has got its own network. So they can communicate, he is running, they can track it, then they can talk about it. They have a control room, they have a location of the terrorist. Then it has to be constantly told by control unit to the moving van that the terrorist has gone to this location and this location. The location sharing is not possible in the present network. And once it enters in the Noida, so there is no communication between Ghaziabad and Noida police other than the mobile handset which they have. Similarly, when it comes to Delhi and then it goes to Gurgaon, so there is a lack of coordination. Now let's come to PPDR. So all of the agencies are on the same network. They can share the location of the terrorist live across all the agencies, okay? So they can see where the currently terrorist is. And then they can communicate, they can share the videos also and other relevant details over the network. So that is one use case. There is another case which is particularly useful for, particularly can be implemented in 5G implementation. That is the critical operations. So there is some critical operations like when Osama bin Laden was tracked down by US agencies. So similar kind of operations are of course done by security agencies and many a times for disaster relief also. So nowadays what is possible that there are variables. So variables can be provided to different commandos. And the entire team was on the same group. The moment the commando who has gone first, the moment he opens the holster of the pistol gun, immediately the entire team will get to know that yes, it has been opened, okay. Unfortunately, if it is having some injury, so the entire team can know that what sort of injury it is, whether it is a bullet injury or some other sort of injury. Even if it is a bullet injury, whether it is on the left arm or right arm, so variables have the sensors and that is detected and immediately informed to the entire team. So they can take action accordingly. So that is another example. Then we come to extreme disaster events. Whenever there are extreme disaster events, so multiple agencies work over there. Paramilitary forces are there, medical services are there, police is there, fire ambulance is there. So we can create a dynamic group immediately for that purpose. So these are the use cases of PPDR network. As I said that it can be integrated with the analog or radio network Tetra P25 and even Polnet through interworking function gateway. The global scenario is that US, Qatar, South Korea, Kenya and others have already deployed PPDR network. UK, Finland, Australia, Canada are under the implementation stage. Brazil, Thailand, France, Hong Kong, Japan, Mexico and other countries have started the implementation. And in China, they are going for phase-wise implementation from one city to other. They are progressing in a gradual manner. In UK, what happened that post 9/11, it was felt that whatever communication they had on that date was not sufficient to cater to the requirement which emerged immediately after the 9/11. So first, there was a recommendation from 9/11 Communication Commission which said that there should be a pan-country integrated network which is capable of delivering mission critical communication. So FirstNet Authority was created in 2012. The mission was to create a nationwide integration of mission critical network. And for that, 2 into 10 megahertz was given to AT&T at free of cost. And AT&T created a network, and wherever now 5G has come up, it has been upgraded to 5G. And with that, the latest features like slicing and other things to provide QoS required and the low latency and other things have also been implemented. So that is the case of US. In South Korea, they have, in the case of US, what they have done is that they have, AT&T has made use of the existing commercial network also. So wherever they have the commercial network, they provided the communication on that. And only thing is that they have made it robust to meet the disaster requirements. And the 2 into 10 megahertz which has been given to them, if there is no traffic from PPDR agencies, then it is used for commercial purposes. Otherwise, there is a priority and even preemption for PPDR agencies. And even that is further being given to other agencies like airport and other things on commercial basis. In South Korea case, they have made a complete captive network for PPDR purpose. I mean, it is not merged with or integrated with the commercial network. It is dedicated network. Again, they have been given 2 into 10 megahertz frequency in 700 megahertz spectrum. There are some 333 public safety organizations working on it. They have integrated the marine network and the railway network also to it. And the implementation has been done from December 2018 to December 2020. So TRA recommendation has one thing that there should be a pan-India network. A framework for that, they have indicated that some SPV should be formed in MHA, which coordinate, steers implementation and the subsequent operation also. Network model has been suggested to be hybrid model, and 2 into 10 megahertz dedicated spectrum should be allocated nationwide in 800 megahertz spectrum, and the pilot testing is to be started. MHA has held meetings recently in last 6 months with different states and UTs. States have expressed desire for implementation of PPDR and for pilot study, and MHA is exploring the locations for pilot study. Way forward is that standing committee is being formed by MHA. Capacity building, we had a conference in DOT also. We invited all of the OEMs and other agencies, telecom service providers, MHA, NDMA. Further work is being done. Then allocation of spectrum is to be done by DOT. Then pilot testing and freezing of user requirement. Once we do a pilot testing, then we can actually assess the requirement of the users. And then network deployment in a phased manner. This is how we are going forward with this. And with that, thank you.
Thank you very much indeed. And ladies and gentlemen, now after the keynote presentations, I hand over to our chairperson, Shri V. Raghunandanji, to kindly carry forward the proceedings of the panel discussion. Over to you, sir.
How and what are the mission critical inside the premises of and also the various types of use case and requirements, and nationwide how the PPDR, the public protection and disaster relief by Mr. Agarwal. So both were actually, it is incidentally both were try recommendations. So I should be happy about that. The outcome of that is seeing the development and implementation. And coming back to the sessions today, Mr. Jitendra Singh from, he is of course, he is Vice President of IIFI. Maybe he can just speak about his, 2 minutes about his own, what he is doing currently, and then take forward his perspective about this CNPN networks. Thank you, Mr. Jitendra.
Thank you, sir. Good morning to all of you. So on CNPN, or also known as private networks, there's activity which is happening globally. If I come to APG activities, Asia Pacific activities, a report was created by AWG in August this year, and luckily this platform, which is IFI platform here, IFI was the key contributor to that report, which was created by AWG, which was finalized by AWG this August. There's another work which is happening in ITUR. Working Party 5D is also creating a report on industry, usage of IMT in industry. And I happen to chair that committee which is working on it. So I have, because of that understanding in this committee, which I get from various stakeholders, on how to utilize the 4G or 5G spectrum for doing, providing connectivity to private network connectivity to industry or of various categories, whether it is utilities, whether it is rail sector, whether it is education sector, different type of sectors, different type of requirements, gas and oil requirement, ports, seaports. So all these requirements are having typical characteristics of the requirement which 5G actually can provide. So you need ultra low latency, ultra reliability in certain cases, and in many cases you require very wideband connectivity. So this is what can be done by 5G private networks or even 4G in some cases. So how do we take care of that? So is it possible to use some other spectrum bands which are not identified for IMT to do this? I think it will be difficult because you are not having that kind of quality of service or parameters which have been established for doing IMT or 5G or 4G because of 3GPP standardization which is there. Other option could be doing Wi-Fi. Again, Wi-Fi does not guarantee you any quality of service, and that is also mentioned by Vichy and their experience about this Wi-Fi in that crane system. So Wi-Fi is not the one which can actually provide you reliable services in most of the private network cases. Third option comes to depending on network service providers or MNOs or TSPs. Again, low latency is one factor which may actually, in those cases, it will not be possible for getting using their resources, network resources of TSP to use or to have a private network. So then what do we do? So it means that we require a separate spectrum, which is IMT spectrum, where you can actually have your own private network. So that is something what as CNP and we know. Again, then it is important to know that if we give certain spectrum to a particular industry or to an applicant of who wants to deploy a private network, so what kind of spectrum are we giving? Does that spectrum have sufficient kind of ecosystem available? Suppose we give 40 megahertz in say band N79, say from say 4450 to 4950 to 4990, 40 megahertz is given. What is that band? That band is IMT band, but does it have any economies of scale in terms of global deployment on that for IMT, for IMT or for private networks? Will that help our industry to actually go for it and then get that benefit of economies of scale? I think that will not work because this is experience which we get from other countries who have deployed networks on different. Or they tried to use. UK is one good example for that matter. That they tried to give some spectrum, which is IMT spectrum, but not close to what otherwise their deployment is in say in C band. So because of that, they had to now revisit that particular assignment of spectrum. So maybe that is some lesson we can learn from them and modify in case our requirements are there. Maybe when it goes to TRA can look into those matters. So if we focus on 3700 to 3800, I think that is the closest band where IMT is already getting deployed in India. So that means that is the band where we can get good economies of scale. Because if we go to some other band, maybe 5,000 licensees, each deploying around 100 CPs, will not give good enough business to any manufacturer for making equipment for them. But if we go to a band where we already have IMT in N78 or N77 band, where there are global deployments, maybe entire Europe, many other countries are having that band for IMT, maybe that can give us good ecosystem which can be then used. I know that 3700 to 3800 is an issue here, but my view is that we have about 270 odd MNOs, registered MNOs in Ministry of I&B web page, which we can see. So managing those small set of MNOs versus number of players who are going to apply for license, I think that can be managed. That is something between those locations, because we know exact geolocations of these MNOs, not MNOs, MNOs and of course these private industries. We know those locations, physical locations, so we can manage those, and we should utilize that kind of spectrum. So this is my initial thoughts. Thank you.
Thank you, Jitendra. You pointed out about the ecosystem, about the device ecosystem development for building the economies of scale. So I'm happy to note that, and of course, TRAI has foreseen through the consultation process this issue, and then we didn't say that, okay, you go for the spectrum, for the particular spectrum for the CNPN purpose. We suggested to DOT, you examine these bands and come back to us, which band actually, in which band and what pricing and what methodology we have to give. So this we have foreseen and anticipated these kind of ecosystem issues. So we will see as and when it comes, we will deal with the process in a holistic manner. And now coming back to Mr. Bhagirath, my senior colleague from DOT WPC, he has a very nice experience, and especially in the wireless. So he can speak about this, anything related to the wireless aspects of, or anything, any issue related to CNPN, or again on the spectrum bands, what Mr. Jitendra Tak has spoken to, he can supplement that. Over to you, Mr. Mr. Bhagirath.
Thank you, sir. Good afternoon to everyone. Sir, in the initially outlined the TRI recommendation, of course, it was examined in the DOT, and the requirement of a spectrum, what kind of guidelines needs to be issued. That actions has been taken by DOT. Post recommendation, the TRI recommended initially 4 options. 3 options have been accepted. CNPN can be established as a slicing of the network, then as a isolated network, and of course the third one through the leasing. Because the different CNPN may have different requirements. Few may have a higher level of security and the reliability of the network. They can opt for the third one. Of course, about the fourth, the direct spectrum assignment, that option is under examination in the DOT, and as TRI also suggested, the legal tenability. So for that also, DOT is working on that, and certainly in due course, all these things will come to know. But one thing is clear here, the spectrum requirement for captive networks should be in the bands of the IMT, which have good ecosystem, as Mr. Jitendra told, because in a band where there is no ecosystem, who will invest in the equipments and all these things, because the ultra reliability and low latency, fundamental, then massive machine type communication, another requirement, and the EMBB, enhanced mobile broadband. So these combination of 3 requirements of the 5G spectrum needs to be that one which have a ecosystem. So then we have to balance between the methodology, how to give a IMT spectrum in the country to CNPN or a part of that. Through that TSP, already it is available. It may be explored. And one thing I want to add here, in this NIA, because in a pockets where spectrum is not given to the TSP, there is a keep of kind of mechanism based on some criteria. So this much amount may be deducted from their revenue to be deposited. So similar kind of mechanism may be developed in due course between the TSPs and the CNPN holders. So, and about that, they can explore at what rate the leasing, because these are the apprehension at this stage, what may be the price, whether the TSP will refuse to a CNPN holder, perhaps we should wait for time being, because there are 4 operators, including BSNL. So let the this some sort of between industry and the TSP, some commercial conditions may develop in due course. Then if some difficulty comes, certainly government maybe based on the stakeholder consultation and all, how the difficulty in the leasing guideline may be amended, or some sort of riders or something may be considered, but not at this stage, what I understand. Thank you.
Thank you, Bhagirath. I know it's a very sensitive issue, and then you are working on that. And TRAI is also working on that to give a methodology which will be consistent with our stand on the whatever pricing mechanism, which will also be acceptable in future. So that not only for this purpose, any captive purpose when we assign, it has to be consistent across all the spectrum ranges. The methodology which we, so we are working on that from our side too. So as and when in the DOT refers back to us on this, we will respond to that appropriately. So coming back to Mr. Vishy Ramaswamy again, so he has spoken about the initial captive networks requirement, the edge computing, and then the isolated network, and also the slicing is always possible for the entrepreneurs or enterprises to work on with these TSPs closely. So anything else you wanted to add on, Mr. Vishy, you can just please.
A couple of additional points, sir. We were, Mr. Jitendra was talking about providing spectrum even in the IMT band away from the typical harmonized band within that country or within multiple countries. That's an important point we should keep in mind, because the device ecosystem doesn't develop that fast. Because here we are talking about device ecosystem not of handsets and tablets, but of sensors, controllers, PLCs and various other products, other cameras and so many other things, which should have an embedded 5G modem inside that, right? Which will suit that particular band. If we take it away from typically majorly used band, very popularly used band, then the cost of the CPEs go up, and that sort of the ROI for the manufacturer or the port or whosoever is implementing is a private network, for them the cost doesn't stack up. The other point is then alternative for that is you end up using certain CPEs which are like Wi-Fi, do use Wi-Fi on one side and then they connect to the 5G on the other side and things like that. Here, this is feasible technically, but then the problem there is, number one, the price goes up because you have to provide for the CPE in addition to providing the device. But more importantly, some of the inflexibilities that we saw earlier, those come back, right? The Wi-Fi performance within that area, because the CPE is going to radiate in Wi-Fi, so that problem is going to come up. Some of the other issues that are associated with Wi-Fi or with Ethernet, they will come back again to this particular thing. So the higher possibility of using a natively 5G device, the better is the network performance and the ROI for the enterprise, right? So that's an important point, because here we are talking about a device which is not a handset or phone, but maybe an AGV inside the campus. The crane, I spoke about the crane, so the crane becomes the device, and so on and so forth, right? And with that, the other possibility I would request you to consider is to look at spectrum in a slightly layered approach. There's a completely unlicensed spectrum that we have for Wi-Fi, 2.45 and 5.8. You have a Wi-Fi network, and there is a recommendation from 3GPP on LTE unlicensed, and also soon NR unlicensed, 5G NRU. So there are going to be specifications there. So how do we encourage people, if required, to adapt that? And how do you ensure that there is no interference between the regular Wi-Fi use and an unlicensed band 5G, which is being implemented inside a campus? So the other alternative is to have a certain segment of the spectrum as unlicensed, but only to be used for industrial use and not for, Wi-Fi type of a use. That's another choice that we have. The other option is to look at shared spectrum. You use it within the campus. The moment you step out of the campus, it's used for public network. And this spectrum can be, and this is very much a possibility because there are, countries where they have implemented software to determine which spectrum is used in which campus, and then based on that, when somebody wants to radiate, they can inquire and find out which is the best frequency that they can radiate within this particular campus. Once they decide that they will radiate in this campus, that particular frequency is sort of knocked off from use, for that area, for that geographical area. So there are these type of options also available, sir, and definitely we can, come out with, I'm sure that we can come out with some good option which is favorable for the enterprises and the industry to set up a, captive network for their use.
Thank you, Vishy. I think I thought that with the four options given, we thought that the dust is settled, and then, but now coming back to, they say that no, we want IMT only, so IMT band only to be used for the, so this is going to be challenging again. You are giving us enough food for thought for TRI to further work upon. So we will see definitely as and when it comes back, and the device ecosystem is a very key point which you are mentioning. We are aware of that. Definitely we will take a note at that time. And so my coming back to Mr. Sushil Kumar, my senior colleague in the TEC, he has got a huge experience of handling on this IoTs, and let us give him a big clap that he recently his contributions have been approved, agreed by ITU, and then we should give him a loud applause. He has worked for a lot on this. Over to Mr. Sushil to talk about the device ecosystem in IoT and other things, especially in the context of captive networks. Maybe you can talk about that.
Yeah.
Thank you. Over to you.
Thank you, Chair, and good morning to all. This Industry 4.0 is one of the most important vertical of the IoT domain. And TEC is working in IoT since 2014 and released 18 technical reports with the outcome intended to be used in policy and standards. A number of outcomes of these reports are already the part of policies and standards, and remaining are in discussion. One technical report, that is the emerging communication technologies and use cases in IoT domain, that was released in November 2021. It is having the detailed study of 5G technology, like release 15 and 16, and release 17 work was in progress at that time. Wi-Fi 6, Wi-Fi 6E, Bluetooth Mesh, and the use cases like cellular V2X and Industry 4.0. In Industry 4.0, the study is on captive network and non-public network, that may be the standalone network, and also the network which may be connected with the TSP's network. This study was done in association with the multi-stakeholder working groups having the industries and the TSPs and OEMs, and it is also having the detailed study of the spectrum which has already been allotted in or was in the process of allotment in different countries. This study was done by GSA, and from the GSA study we have captured the spectrum which were being allotted. They were in 1800 megahertz, 2.6 gigahertz, 3.5 gigahertz, 4.8 gigahertz, 24 gigahertz, 26 gigahertz, and 28 gigahertz. So as already mentioned by Mr. Ramaswamy, that we should have the ecosystem where the devices should be cheaper. If we are having we allot the spectrum for the captive network from the IMT spectrum, it will be easier to have we will be having the device ecosystem, and the devices will be cheaper. And this document is also having the recommendations for the spectrum as well as regulatory issues, and these documents were already sent to TRAI and DOT and other organizations, and these recommendations may be helpful for further study. And in fact, these 5 technical reports, which are the part of the 5G ITU portal, they have been posted recently on ITU portal, and one document is this one, and other document that the 2 are related with the IoT security, because from the network, the device can be hacked, and from the device, the network can also be hacked. And in one of the study made by European Union, most of the these segments of the 5G will be in the cloud. Therefore, this 5G core that should be tested, and they have mentioned that there may be chances that the 5G core may not be on 3GPP specifications and others, then it may also become vulnerable. And from the network, the devices may be hacked, and from the devices, the network may also be hacked. So this security may be a big challenge in this. And NIST, 3GPP, and GSMA, and many other organizations, NISA and others, they have released the security specification on this. We are also working on the IoT security segment in this. And we hope that in future, the spectrum for the captive network in for Industry 4.0 will be allotted, and we will be having a number of smart factories, and our OEMs will be able to develop the smart factories across the globe, not only in India, but across the globe, and we will be able to provide the devices which can be exported. So we should have the devices based on standards and the open interfaces. TEC has also adopted the 1M, 2M Release 2 and Release 3 specifications, which are related mainly with the IoT platforms, as well as the 3GPP Release 10 to 16, and Release 15 and 16 are for 5G. So 5G is having the features which are not available in the previous generation technologies, that is 2G to 4G, and will be mainly used for the industry verticals, Industry 4.0, and cellular V2X will be one of the most important verticals, because CV2X will be deployed on the TSP's network, and it is the requirement of the country. And there is no other technology. Earlier, the DSRC was the technology which was developed by in US in 90s, and it is more or less outdated. So now this 3GPP CV2X technology may be deployed in the country, and we should have the ecosystem for this also. This for V2V communication, this WPC has already allotted, earmarked the spectrum in 5.9 gigahertz band, and we hope the CV2X and the Industry 4.0, which are the 2 big verticals of 5G, will be deployed in the country. Thank you.
Thank you, Sushil. And what I should say in the end, actually, to sum up, I must say that divergent views are there. It is nice, actually, about the requirement of CNPN. I am happy to note that DOT has taken TRAI's recommendation and then worked on that, coming back to first PPDR requirement. We had quite a lengthy discussion in my chamber, Mr. Agarwal and myself, that even though it was recommendation was 2018, how hybrid network can be evolved, and then I'm happy to note that they have taken into consideration the discussion part of incorporating the 5G, especially the slicing. The technology provides slicing for the PPDR, especially used for that. A hybrid network can be used. So one is that has been taken care, and then we look forward for the PPDR implementation at the earliest in India. And then Mr. Vishy's requirement of using these, and also Jitendra, and then many of the people have spoken that the spectrum requirement for the captive networks has to be in the very close to the IMT, so that the device ecosystem scaling up can be done. So that is the reason why, if you see the 4 models which TRAI has given, it fits into these 4 models, whatever your requirement. Say, for example, you have the captive isolated network. There are n number of manufacturing unit. You will have a captive, then you can have the edge computing, and you can have the central core there. So then the TSP's core network comes into picture. That is, in the sense, slicing comes into picture. That solution. If you wanted to have a very highly mission critical, you can go for a captive isolated network. That option 4 comes into picture. And then for requirement like mining, mining requires again, you may or may not be able to set up a captive isolated network there with a core and then everything there. So because of the environmental conditions there and then kind of infrastructure there. And you may require 700 megahertz, that is sub-GC band, as well as the mid band, as well as the millimeter wave band. So all these things cannot be actually that is the reason why we have even recommended that one enterprise can take the slicing or whatever requirement from the different TSPs also, depending upon the strength of the TSP. So if you see that all the 100-page document, so if an enterprise wants extremely mission critical, no, I wanted to have a core network here and I wanted to use captive, 100% captive, and then you can use that. There is no doubt about that. The only thing is that now the ecosystem part of it, that we will see as it evolves. Definitely TRAI also will, you please, whatever we have spoken here today, I will come back to you. Please give us in writing, because TRAI will go through only the consultation process. So these discussions only I am just putting across a broad perspective. So we will look forward for during the consultation again, whatever additional inputs come to us, we will accordingly act on that. So with this I can ask for take for one or two questions. Yes, please. Either to the panelists or to me. So not necessarily to me.
Can I go?
Yeah, please.
Yeah, thank you, Mr. Chairman.
Please,
I want to compliment all of you and especially Mr. Vishy for making so many things clear, actually, as Secretary mentioned. And of course, I have one suggestion, one question. So first, the question is like for a captive network, most of you are agreeing that it should be this IMT spectrum, whether 4G or 5G, whatever. But there is a technology. Actually, normally for such thing, the option of the technology should be left to the owner or user, in this case, the enterprise itself. So for that, there is one thing comes to our mind is, why not to use unlicensed spectrum like Wi-Fi? Now Wi-Fi 5 is there, 6 is there, 6E, 7, 8. Wi-Fi 8 is coming and Mr. Puri is there in the afternoon. So I think why we don't have a debate or a option given to the enterprises to use Wi-Fi. And then there is another technology called LTU. LTU means LTE unlicensed. So you can have IMT technology on an unlicensed band. So because there is a debate whether to give them spectrum or not, but why not we have an option, and that looks like a low-hanging fruit option. And ecosystem is already there. No ecosystem can be better than the Wi-Fi, as all of us know it. So what are your thoughts? And especially, I think Jitendra and Mr. Vishy, you will have to answer. And then I will come back with a suggestion also.
The question is to him, no?
Yeah, to both of them, but Vishy first, then Jitendra.
So, I did mention about LTE-U and 5G NR-U, later on. Now, there is definitely a recommendation from the standards body to use unlicensed spectrum for LTE, and now also recommendation to take it to 5G as well. So there are, in the LTE-U at least, 5G-U is not, 5G NR-U is still not ready, it has not become popular yet, it takes some time. In LTE-U, there are a few things which we need to keep in mind. Number one, the device ecosystem is not great in LTE-U. We have been sort of doing some trials and we have identified that you don't get devices that work on a standalone LTE unlicensed. You get LTE-U only when you have an anchor band on a licensed LTE and then use LTE-U for offloading. There are some device ecosystem available, multi-band handsets, etc. But if I go back for industrial devices like a controller, sensor, any of those things, in LTE-U there is no device ecosystem. That's one part. And why can't we use Wi-Fi? So choice of using Wi-Fi is always there for enterprises. A lot of people are using. what we have identified recently by talking to various types of manufacturing units is that there are certain limitations that come by when you use Wi-Fi. For example, the number of access points that you need to install within the premise and accessibility to install access points, because you have say this crane yard that I just mentioned. You have about 150 to 200 meters width and about 300 to 400 meters depth, and there is crane moving and there is hot steel below. So in that case, going and putting multiple access points on the ceiling for you to get a wide coverage is a problem, right? And we have seen that problem in multiple other industries. I'm just keeping that steel industry in as an example because there's a continuity on the subject, right? But I can pick up any other industry and also explain the same way. But hence, these issues about number of access points that you need to install. Second thing is the mobility. There are AGVs, AMRs inside the campus. The mobility handover, because any cellular technology is naturally built for mobility. The handoffs are designed, and hence it becomes easier for them. But with Wi-Fi, there is a problem with the handoff, right? So there are some issues, depending upon the specific industry, and there are industries who have tried some of these technologies before, and they have not been able to implement what they want to implement. Finally, at the end of all this, their intention is to implement that automation, implement that video surveillance or a video quality assurance or whatever application that they want to implement, right? So they have tried, many of them have tried, and if it works for a given industry with Wi-Fi, why not? But there are equal ratio of companies where they have tried with Wi-Fi and did not work. And they find that cellular technology would be a better one to solve that particular problem. And that's been proven across in the world in various places and various types of industries how captive private networks have solved the problem for them. And hence, there is an inclination to implement a private network. Right now, so hence, there are options available, LTE-U, Wi-Fi and all that. But in our view, there are challenges associated with some of them, and that is the reason why the enterprises want to move towards a captive private network.
Thank you. Jitendra, you can add something?
Thank you. Actually, Vishy actually covered that part. When I was speaking, I actually said that because of various kind of requirements, whether it is low latency, ultra reliability, high throughput, mission critical operations, all this will require different categories of networks. One, it can be operator driven, it can be dedicated, it can be Wi-Fi based also. Again, this all will depend on what is the use case. And if that use case permits Wi-Fi, people will do Wi-Fi. If it does not permit Wi-Fi, people will move to technology which gives them more reliability, because that may be the case. So it is not only that manufacturing is the only use case we are talking about in private networks. There are different kind of use cases, whether you are talking of mining sector, oil and gas sector is very typical use and a typical requirement, and they are cannot depend on Wi-Fi at all. So they require, and they cannot even, they want to be totally private. That is the kind of requirement of oil and gas sector. Then probably retail sector may use Wi-Fi kind of solution, but healthcare may not use Wi-Fi kind of solution. Again, it depends what is the requirement. So I think what Vishy said is how it actually goes. And regarding ecosystem, again, whole thing will come back to ecosystem, because manufacturer, or whether he is the person who is actually manufacturing the devices, whether he is getting his business there or not, that will also count. So if there is no good ecosystem, or there is no demand, suppose we have 10,000 units who are actually demanding particular CP or particular kind of requirement for private networks, it is not necessary that that 10,000 unit is good enough for someone who is producing or making that, manufacturing that kind of CP, because that is very weak demand for them. So they may not even make that equipment. So therefore, how to get that right ecosystem, whether it is LTE-U or whatever. One of the reasons for LTE not picking up was one of these reasons, because that same band you also have Wi-Fi. So maybe people prefer Wi-Fi over that. So again, in my view, it is more of demand. What kind of requirement is there on ground?
Okay.
Lastly, one other small point, sir.
Yes.
In some of the applications, what I just missed, Jitendra was mentioning that, places like retail, hospitals, ports, airports and all that, you will have a coexistence of both, because you will have Wi-Fi for a certain set of applications, or they're using it for it, and public network is being used by all the people who are moving inside, and there is a need for a mission critical OT network that requires a private network. So you'll also have coexistence in many of the places.
Yeah, thank you. And Mr. Chairman, one more point is regarding like 4 options which you mentioned, and all are telling like no size fits all. And so why not someone, either the telco or the like some industry, or maybe even our own ITU, FET, do what we call a TCO kind of cost benefit analysis. Like what option will provide the lowest TCO, the total cost of ownership, like whether I take a slice, or I use a license spectrum by buying the spectrum, or I use other technology. Someone who should be the best one to do that TCO or a cost benefit analysis for the enterprises, because they are not expert in these things. But they have a need, they have a problem to be solved, and they feel the telcos cannot solve that problem. That is how the whole debate about the private network came. So now the 4 options have been given to them. So like obviously they'll be confused which option. So who can do the TCO, and whether that will solve the problem or the confusion will still remain? Thank you, Mr. Chairman.
Anyway, if somebody else has to answer this question.
Thank you, sir. So it is actually a good idea to have this kind of activity done to understand what is best for enterprise to actually go about. But there are so many variables here. What spectrum? What is the ecosystem if that person goes, or that industry goes alone to the market to get the equipment? What is the cost factor? What is the spectrum which is given to them? At what price it is given to them versus what is given to operator? What operator has got? How operator is going to charge that particular enterprise? What are the parameters between, or what are the agreements between them? What kind of quality of service which gets? So there are actually large number of variables here. So one has to fix those variables before actually getting into this cost.
Sure. These points actually have been extensively discussed before giving our recommendation, these 4 options. So the total cost of ownership point was well discussed, because if TSP gives the enterprise through the slicing and then the ecosystem scaling up, the economies of scale of the ecosystem, and also taking care of the entire network without interfering in the other side, at the same time ensuring the public network quality of service as well as the quality of service of within the enterprise. These things were actually extensively discussed. And then it is a collaborative effort. Again, I'm coming back to you, all of you. I use the word 3 C's, Mr. Vikram Devatia knows 3 C's: collaborate, coexist, and then converge. Convergence is the way forward. So collaboration, I'm happy that somebody used the word coexistence. So then the collaboration. See, 5G and above technologies, no independent. Supposing, for example, I have got a pipe, what I will do, 5G, unless I have a application ecosystem. So it has not one service provider can bring up applications across India. Millions of applications will be required. Then only the 5G's true potential can be realized. So the convergence, definitely the technologies are converging, and then device ecosystem also is converging. We need to take care of that also for the economies of scale to happen. So these are the 3 things. Collaboration is the key mantra. I'm telling you, to working together and then coexisting is the key aspect of our future. Because definitely the small potential startups can give a huge innovative application which will give a breakthrough for some of the use cases for the service providers to use on. So that is what actually the key thing, we need to work together. And then these models, you have raised a correct point, these were extensively discussed, this has to be taken forward. The way forward is that we should know where I should use the TSP's network or I should not. For example, I gave MSMEs. MSMEs, can they do on their own, taking the 70 million. So 7 crore is key. That is why during my opening remarks also I have talked about that. So we need not have to, we should not actually focus on one alone or anything. We have to address the things holistically. When we talk about the, I'm happy that you used the word TCO. TCO is nothing but a holistic approach. Total cost ownership. So then you have to have a collaborative approach. Okay, this part enterprise can do, the remaining part TSP can do, we can come together and find a solution. So this is the way forward. Definitely if you start thinking, isolated network doesn't mean that mentally we get isolated and work independently. We have to, it is a network which requires isolation. Technically it requires an isolation that need to be discussed. This is what actually my urge to all the industry stakeholders, come together and collaborate and work together. Thank you.
My name is Vimal Vaklu. Actually, till today morning, till maybe half an hour back, I had the impression that for private networks, there's going to be a separate spectrum and there will be no challenges either way. Now that because of the problems which would be there in other bands other than IMT bands, by virtue of the overall ecosystem, it looks like they need to be accommodated within the same band. Now the problem there would be there are a lot of enterprises here and maybe a lot of them would like to have their own captive networks. If that happens, the only way to decide on the price would be, of course, auction. That's the only way out. Now, suppose the auction is the only way out, the prices can go up depending upon how many people are competing for that. If that goes up, then the challenge for the same band would be for the telecom operators also, they'll have to match those prices. So there can be frequencies, spectrum squatting also by virtue of some of these private enterprises. How do you address that challenge? This is my first question. Because I'm not talking about the current government, maybe they have a solution, maybe in future, we don't know what happens. Now, second question is that if ecosystem, economies of scale is a challenge. Now, like we had PPDR earlier, we had Tetra systems, it's at a global level, and the prices and because the number of devices is large, because it's serving the entire globe. So why can't we follow the same template for even the private networks? This is my second question. Thank you.
I want to answer the
Something, if required, I can supplement.
the first question. Because as per the discussion, industry wants CNPN, for CNPNs, the spectrum in IMT band, because ecosystem is available. And where the spectrum for IMT is available, government has auctioned it to the TSPs and the rights has been given for 20 years. Third option is a good option for industry. You talk, sit together with the TSPs on the lease basis, because your geographical requirement may be different, where there is no public. So, and they need money, because their spectrum may be idle in that area. So they can give you on lease. Subsequently also, they can rearrange their requirements, putting by more towers, they can spare spectrum for you. So industry will get exclusive allocations, requirement of spectrum for them, but the option as per the law of land as on date will be the third, through lease. It's a optimum utilization. There is no legal issues in that, and you can go ahead. And for example, Tatas are good in hotels because you can take 1-2 rooms for the lifelong on lease, and they can accommodate, they can rearrange. So similarly in the networks also, you will get a spectrum, but ecosystem for the investments, better you go for the good spectrum bands rather than demanding for the spectrums on administrative in those bands which have no ecosystem, because ultimately the money matters. So that way, sit together with collaboration with the industry. If issues comes, certainly government or the TRA regulator will come into picture, because mechanism will be done to give a long, say, life of the networks, how to, after the expiry of the licenses, because in the earlier networks also, so continuity, certainly there will be some provisions that time, maybe after expiry of the one TSPs, how it will be dealt that time. So not to fear at this moment, That's all.
But I don't think that addresses my first question. Because I was talking about the spectrum, costs going up. The spectrum costs going up because some private entity bids high. So that becomes a template, that becomes a benchmark. And all the service providers will have to match that. That's the question. If it is in the same band.
Sir, your requirement may be for a limited period, a limited area, not the LSC. And one TSP cannot bid higher because it's a mechanism. There is a spectrum cap. One cannot bid more than that quantity. Then 3-4 operators will be there. Then LSC, then for that geography, on the population-based criteria, what will be the pricing of that? That perhaps around that pricing you have to pay between you and the TSP.
I'm not talking only about the mining sector or the oil and gas sector. I'm talking about enterprises in general. So enterprises in general, they can also gang up together, hold up some spectrum, bid high, and that becomes the benchmark. And there has to be some sort of a mechanism to prevent even spectrum squatting.
Let me just address broadly. I have already told you that let the current demand assessment process by DOT be over. Let the reference come. We have come back to TRA. So all your concerns will be addressed. I should not speak at this stage being a TRA secretary what we are going to do. So it will evolve through the consultation process, and then we will be giving appropriate recommendations. That much I can say, which will address all the concerns.
Now the second question. Should I repeat that? No, internationally, in the past also, for PPDR and other things, you have TETRA. Then the device prices are regulated because we are using the equipment globally. That's how it comes within a reasonable range. So why can't the same thing, same formulation happen in the case of private networks?
Thank you. Good question. On first question, we'll discuss with you separately also. On second question about these devices, that is exactly what I also said, that if we have bands which are aligned globally or even regionally, that is what is going to help. And that is exactly what industry is doing. So if we see how different countries, either in Europe, Japan, Korea, China, all these big countries, US, how they are actually looking at these bands and how they are looking towards their industrial requirements or enterprise requirements. So this is already getting aligned globally. It is too early to say that everyone is aligned. No, that work is still going on. Different countries, based on their availability of spectrum and usage of spectrum, they are working towards this. This is already a work in progress.
Actually, I want to bring to the notice of this forum. Are you aware that NEC is implementing connecting all airports in Germany with the private 5G public enterprise? I think this note would have been, I would be aware of it. I think same thing can be implemented in India also, no? NEC is a vendor which is doing a private 5G enterprise across all the airports in Germany, and it is getting connected. And Dutch Telecom is helping NEC to get it done. Hope are you aware of it? I given this note to this message to it came in RCR Wireless Forum to our esteemed secretary to DOT K. Rajaraman when he took over recently from Anshu Prakash sir.
Anyway, we are in the beginning of 5G implementation, and we have done a pilot in one of the airports also. Mr. Vikram also was a part of the whole process of doing the pilot. One port, one airport, then one metro, and then like that we have selected 4 sites, one city for the smart city. So the processes and then the way forward, how to address the various regulatory and the implementation aspects. As far as this commercial is concerned, which airport to be implemented by NEC or by Tata or somebody else, so this is the commercial aspects. We will see as it evolves. Definitely people will adopt the best practices, and also the total cost of ownership again there comes into picture, whether I have to use Wi-Fi, I have to use 5G, whether I have to use the fiber optic, and then all other things. For example, in my TRA, the new building, I will be discussing with all of them. Definitely, we would like to have the most advanced, state-of-the-art when I move on to the new building in TRA. So here, of course, there are some constraints. So we are planning there the best thing. So we will have a fiber optic, we will have a Wi-Fi when somebody else comes on this, when we will have a 5G AR, VR experience in all our conference halls there. So it is going to be a different model altogether. So what I require, I will plan, I will design. So if I don't require, I will not design. It is as simple as that. I have just given my own TRI example. I have planned from 2G to 5G. In the sense 2G is required or not, I will plan. Wi-Fi is definitely required because public wanted to enter and meet us. They can have Wi-Fi there. If they want to have a 5G experience, we will have a 5G. In all our conference halls, in TRI, we would like to have definitely the most advanced AR, VR technology is there. So my basic point is that it has to be a collective effort, collaborative effort to sit together, and the requirement has to be finalized. What is the cost actually ultimately comes into picture, where the commercials will, so I should not enter into these commercial points of it. We come into picture only the pricing part, if at all, if we have given to the forbearance, that is why we know that industry innovates and then brings up with a larger principles of transparency and level playing field. These are the larger principles of this thing on which we work and then give it to the forbearance with an oversight mechanism. So I think it is too early to talk about a particular vendor coming up and then doing it. Let there be n number of vendors. The potential in India is huge. The 1.4 billion market is there. So let us wait for that. Thank you.
Sir, I have a question for Mr. Sanjay Agarwal. This side, on your left. So you talked about the PPDR and then planning the PPDRs on 4G and possibly later on graduating them to 5G if required. What I wanted to understand that you projected a requirement of a separate spectrum bandwidth that is of 10 megahertz in the 700 megahertz band and a different captive network for the public emergencies communication. What I wanted to understand from you, has this aspect been explored that where LTE 4G offers us the technical parameters like QCI, ARPs and the guaranteed bandwidth on defining the QoS, then is there a separate need for the captive network because emergencies can happen anywhere, whereas the commercial networks are spread out all over the country? And with a few telcos only remaining and having the access to the spectrum, which also becomes an issue in case a separate spectrum is required. So technically, has this aspect also been explored of defining QoS using the QCI parameters, the ARP and the GBR?
As far as this, the release 13 onwards, the PSLT specifications have been embedded from 3GPP release 13, 14 and of course 15 onwards it is there. So the QoS and the preemption and the priority and the mission critical communication involves that within 300 milliseconds the call should mature, even group call should mature. So all those have been taken care of in these releases first. Second thing is that as far as the implementation of captive versus dedicated network versus a network which is using the commercial thing, so that depends on the cost. If we are having a pan-India or pan-country, any country, captive network complete, so it is going to cost huge. And
correct, sir.
So that particular thing is being considered. And in South Korea only so far the captive network has been there. Even in US they have gone for the other option because it is a very vast area, large country. Similarly for India, we are considering the option as it has been implemented in FirstNet.
So does that imply that the existing commercial networks will be the best network for the public emergency communication?
I cannot finally comment upon that, but we are the thinking process is in that direction.
Yeah, because only then you utilize the technology also fully and again save on the capital and the infrastructure.
Yes, correct.
My next question is to Mr. Vishy. You mentioned about the 4 options that you gave for the spectrum. Ultimately, as a conceptually, spectrum reuse is the efficient way to manage the spectrum. So while you plan the spectrum for the enterprise, it's a function of the power and so many other things. So how has this, can you just comment on this aspect of allocating the same spectrum which is already available to the telcos and by having the parameters defined around it by means of controlling the power so that they don't interfere with the other enterprises. Because enterprise won't need a long coverage in that sense, or the area coverage.
No, it depends completely on the nature of the enterprise. I wouldn't say that there is one solution which I can say that sort of covers all the types of enterprises. The requirements for a mine is going to be quite different from the requirement for a technology factory is going to be different from a process factory. It's going to be different from a steel manufacturing unit. And similarly, if you go to a port or a warehouse or a hospital, the requirements are quite different in each one of these. So in some, there is a coexistence requirement because the public network is required because, like, let's take a hospital case. You require public network because all the patients and everybody who is coming in, the attendees for the patients, etc., they require coverage. So there's a public network has to be there. They can't say that, no, the moment I enter the hospital, I have to stop my phone or switch off my phone. That's not feasible. So public network needs to be there. And you require some network to connect all the instruments which are used within the hospital, and you require some network to also connect the doctors and the paramedics who are there inside the hospital. So that requirement cannot be the same, or you cannot solve that requirement exactly the same way like you go to a mine. In a mine, there are few people who are moving around, but most of the place is unutilized because empty. But then there is a serious coverage issue as you go inside the pit, okay, or if you go inside the underground tunnels, right? So the requirements for these two are quite different, and based on that is when you will be able to say whether a public network which is there surrounding that can be reused, or do you require a dedicated spectrum to use that, or should the operator vacate the spectrum in that area and hand it over to the enterprise to set up a network. So all of these possibilities exist, and it will completely depend on that particular nature of that particular enterprise.
The time is up, and thank you all for patiently listening to all of us. We look forward for your fruitful discussions and then inputs during our consultation process on this issue further. Thank you. Thank you, organizers.
Thank you very much indeed. I would now request Mr. Raghunandan, our chairperson, to do the honors of presenting mementos as a token of gratitude and appreciation to our panelists. We begin with presenting to Mr. Vishy Ramaswamy. Thank you very much indeed, sir. We present to Mr. Sanjay Agarwal. We present to Mr. Bhagirath. And to Mr. Sushil Kumar. Yes, sir. Thank you very much indeed. And we now present to Mr. Sushil Kumar. Thank you, sir, for doing the honors. I would now request Mr. Jitendra Singh, Vice President, IAFI, to kindly present to our chairperson, Shri V. Raghunandanji. Secretary, try. Thank you, sir. And can I now request for a group photograph? And ladies and gentlemen, with that, we now break for lunch. The lunch is once again served on my right-hand side. And the next session will commence at 2 o'clock. I would request everybody to be seated back in time. Also, for the eminent speakers of the